Last presentation here. So we have Dave Brewer here from USC Utility Supply Corp. Dave has been involved with the waterworks industry since 1991 and has worked with manufacturers in the underground water and waste markets in Canada in capacities ranging from inside sales to general manager. At USC, he works with companies including Smith Blair, H-Tech, US Pipe, and Copperhead Utility Locating Systems to serve the underground utility markets. These markets include public works, consulting engineers, and contractors. Period. In the past, he participated on AWWA standards committees, including AWWA-C219 and 226, and served 2 terms as president of the Municipal Services Association. So Dave will be presenting on the use of all types of plain end pipe bolted couplings. Pass it on to you, Dave.
So, can you hear me? We're good? All right, cool. Wow. I honestly did not expect this many bums in the seats at this time of the day. So, first of all, a big hand of applause for you guys. Look at you guys. All right, so we're going to try to get through this so you can get out and while you're still awake, okay? So we're going to cover bolted couplings, all right? So every utility has a bolted coupling in their system. So here we go. And first of all, big thank you to the EOCP for inviting me up here again to do this. I've been here from the beginning, and I can't tell you, I am, as a manufacturer, so impressed with this conference, and I look forward to the future ones. So a little bit about myself, just so you know where I'm coming from when we talk about this. I spent 24 years with Robar. I then left for an experiment to work with PVC. Found out I didn't like it, so then I went back over to what I know best, and that's working with Smith Blair and pipe product accessories. So 5 years with them now. I have had pipe, well, actually I've worked all the way down to half-inch. Biggest system I worked on was penstock number 5 with Revelstoke Dam. I did not like that. I would not do that again. But in any case, all sorts and sizes, all types of pipes. We all know that one, right? Asbestos cement, well-established waffle pattern on the outside. PVC, used every day. We get out of this market, it's the predominant pipe in Western Canada, period. FRP, right? Anybody ever put a Barsky tank in their wastewater system? You're going to have FRP nozzles coming off of that, so we work on that. This, if we took about a 3-minute walk from here, we would find a pipe that is made of steel that is from 1917. In downtown Vancouver, that was a repair that had a real bastard-sized pipe, so we work with old steel. And then right beside it, brand new ductile, stainless steel, concrete cylinder pipe. Okay. Hyprotech. Hands up, who's worked with Hyprotech? Everybody's going, what in the hell is Hyprotech? Well, I didn't know either until Medicine Hat called me up and said, hey, we got some concrete cylinder pipe that's leaking. I said, oh, okay, I can work with that. Then they showed me pictures. I'm like, God, that doesn't look like anything I know. So I have an old colleague in this industry. Some of you may know him, John Braun, formerly Canada Pipe, now with US Pipe. This guy is an encyclopedia of knowledge. He looked at it and said, oh yeah, that's Hyprotech. I go, hi, what? That is concrete pipe that is coated, not lined, coated with cement. So when you open it up, it looks like a cement pipe, but it's actually got a thin veneer. It's a fiber cement, and it's just as a corrosive inhibitor. You have to take that concrete off the exterior of it to put a coupling on. So now you know Hyprotech. Yes? No, sorry. I am so sorry. You're right. It is ductile iron. I apologize. It is ductile iron coated. And that's why John knew, because he worked with ductile iron. I won't couple that pipe, just in case you're wondering. I won't couple that. So that's actually not too far from here either. So we're going to go into, for like I said, most of you, this is going, yeah, I know this. But if I can get to those 5% who maybe don't know it, and help them in the future when they do an install. That's our goal today, guys, okay? So we're going to cover the bolted sleeve-type couplings. So they've been used for over 150 years now. There's, I don't know how many manufacturers. When I wake up every day, I got probably 7 competitors just in North America. Then we probably got at least another 10 in Europe. There's a lot of manufacturers. They all differ in types that you can, and how they achieve it. But they all have a center sleeve, end rings of followers, and threaded fasteners to tighten and pull followers together. So that means we've got a center sleeve. That's this right here. We have followers. That's these right here. And then we have gaskets that are wedge-shaped to fit inside the sleeve, the tapered sleeve. And then, of course, a set of fasteners to draw it together. There we go, followers, gasket, mid-ring, and fasteners. Pretty simple. Dresser, everybody, when I first came in the industry, it was called a dresser 38. It wasn't called a row bar, all right? It was called a dresser. In fact, if you go back to Ontario, they call it dresser still, dresser 38s, okay? So we tighten these fasteners on at the end, that draws this in, and what we're doing is we're crushing this gasket to about 30% compression. We're crushing it, and when we do that, we achieve our seal. Where is the seal achieved? Just out of curiosity, if you guys look at something and you're suspect on whether it's going to be good, is the seal achieved here or there? Right at that point. So if you see some sort of flaw right here, it's not as critical. You're sealing right there every day with that one. The new generation of 2-bolt couplings operate in a similar fashion. The gasket is compressed in its installed position until a seal is received. So this is a good cross-section of utilities. How many people use this old style, dresser style coupling still in their system? Okay, okay. And how many of you have transitioned over to the 2-bolt system? Okay, all right. So there's both of you, brace your hands. Okay, that's interesting. They both achieve, they crush the gasket until they get to a long-term seal. How they do it's entirely different. And I'm just showing here, this is how it works. There's a new technology out now where they're actually pulling from both sides, where this old style pulls from a singular side. This is actually important because when it works like this, my gasket pulls on that side, then it says, I can't squeeze anymore, then it pulls from that side. And that I'll come back to that later. When we pull tangentially, we're getting that equal compression around the pipe simultaneously, okay? The other thing that's real important, when we tighten these things up, these can walk, right? Hands up for those of you who have tightened these up and you say, oh, these damn things are walking down the pipe to some degree or another. It's inevitable it's going to happen. Your alignment's not right. You got 2 different ODs that you're working with. These ones, both sides are independent of one another. So you can tighten up one side fully, it would have 0 effect on the other side. But they both have center sleeves. They both have followers. They both have fasteners, all right? So that's critical because in order for me to come to your utility and say, I want to sell this to you, somebody in your utility is going to say, does it meet the requirements of EOCP2022? That's the standard we all follow as utilities in North America. And I can say yes. Okay? And of course, gaskets. This is one that I think for the most part, utilities and contractors have become fairly educated to it. Working with stainless steel is finicky. And it's not always required, but if you've got soils that are somewhat hot, you're going to use a stainless bolt, all right? Stainless steel is a very finicky metal. It doesn't like friction. Anybody had a stainless steel that they put together, a bolt they put together in something like these, and it tightens up, and you go, well, hell, this gland is still loose. You fused it, so it's welded itself. It's done. Cut it off, put a new one in there. So most manufacturers now, you can see we have a coating on these. The nuts are blue. They're not stainless. This is a stainless nut, but they have a coating on it, and that's to provide a lubricant on there so we don't build that heat and create the friction and gall the bolt, all right? If you don't see that on there, it's a good thing to throw a copper coat or some sort of lubricant on there that's going to reduce that friction. I get the question, should I put it on there anyways? Well, that can work against you. If you've already got a lubricated bolt and you put additional lubrication on there, what does that do to my torque that I have established at the factory? It's going to go up exponentially, right? I don't have, it's, if you are going to take it apart for whatever reason and then retorque it, a little bit more is probably not going to hurt it, but putting more on the onset, we're going to really compound that torque value. Now, I say that because on these old ones, probably not going to matter. We're dealing with ductile iron. It's very malleable, right? These new ones, they got steel that's all pressed and cold formed. It's going to make a difference, all right? The other thing that I find it's a little frustrating for me as I work with the utilities in the Lower Mainland especially is that there's coating. So we have C210, C213, C550, that's more for the hydrant guys. These are coating standards. So if you put a coupling in your ground, you want to make sure you meet either C210 or C213. They might C550, I doubt it. Why? Because that's a recognized standard in North America for how I put my coating on there, all the way down to bare white metal, and then putting my coating on there, whether it be electrostatically or liquid applied. It also means that I'm going to have an NSF 61 coating, and I cannot believe this day and age, with as much care and time we put into operators and training, that I see couplings out there that have 0 NSF 61 certification. How do you know? How do you know, Dave? I can tell you this. If you've got a coupling in your utility right now that is painted red or painted black, it has 0.0 NSF 61. Why? Because there's either a volatile in there that they cannot prevent from leaching into the water, or it's got lead. And this, you would never see a red painted coupling or black one in Ontario ever. Why do you think that is, guys? Ah, yeah. But here I can probably drive 10 kilometers, 15 kilometers and find them sitting on utility shelves. And I'm not blaming utilities, but you need to know that. Don't assume it's NSF 61 approved, okay? The most important part on a bolted coupling is going to be this gasket. This gasket is your lifeblood. It's why we call them flexible seals. They isolate the pipes from one another and they float in there, all right? So the compounder material used in the gasket must be capable of retaining a pressure load, temperature variations. Go to Prince George, we get up to 30 possibly in the summer, and then we go down to minus 30 in the winter. What do you think that's doing to the gasket? Vibration, impact, we got a big dump truck. Man, I'm sitting in my room working, all I hear is this heavy equipment. How do people sleep down here, by the way? Anyways, all I hear is dump trucks and heavy equipment running up and down. All that load is being transferred through the soils. Our couplings do what? They isolate the pipe from receiving those stresses by taking it up in the flexible gasket. The flexibility of the coupling joint is obtained by deformation of the gasket. That's why we give you a torque value. So we can get to maximum compression on that gasket, and then you're allowed to twist and contort it the way you want. So the stresses are accommodated because we're isolating these two pipe ends from one another, right? Actually, Metro Vancouver is probably the leader of this. They do pipe, like an average size pipe for them, I think is like 88 inches now, or 96 inches. That's an average size for them. But everything they have to have where they've determined there's going to be stresses put into the pipe, they put a coupling on, because they want to isolate the two ends from one another and having those stresses flow down the pipe. Because what happens if those stresses build up in the pipe? We're going to have a failure, right? So they play a critical role. Whether it's a coupling, a mechanical joint sleeve, what have you, we're creating those points where they can have the stresses separated. But the most important thing that's also there is it's floating in there, right? You don't see it when you put it together. It almost looks like a rigid entity, but those two ends are floating from one another. A coupling joint is typically usually referred to as a flexible joint. This is because it will absorb without leakage or damage all ordinary stresses produced while the coupling is being installed. This also includes those caused by expansion and contraction, as well as deflection, vibration, movement of the line, and once it is installed and operating under pressure. So Very typical installation that we see here, done every day. Oops, the pipes aren't in alignment, right? And then this is just a real rough sketch. They do this. Why do they do this? Because if we don't do this, we're going to break this little stub end coming right off the tank. So we get settlement. The deflection is taken up by the coupling. Okay? And how do we accommodate that? We accommodate that because these two ends are isolated from one another, and they're moving in the annular space within that sleeve. Okay? It's really critical that they float. And what's the other thing that's really critical there, guys, for them in order to do that? There's one other real critical factor, which I often see skipped by installers. Well, that plays the major role, but the biggest role is that, nailed it. I have seen people say, okay, with the coupling on, boom, they'll go the pipes together. Hey, do it up. It's going to be a good seal. How the hell is that going to be a good seal? Now your pipes, if they want to move, the stresses can now be transferred into the other end. And they can really fight the coupling. I'm going to show you why that's critical in a moment on the tables here. So again, it's floating, and we have the pipe gap, and we also have that annular space up top. So like I mentioned, there's standards for these, C219, C213, 210 is allowed as well. You also get expansion and contraction, okay? So, well, how unprofessional is that? I have the Township of Langley calling me up right now. Well, I'm not, this is live. I'm not touching that. Are you crazy? So this is from C219. These are minimum values, okay? So if you need more values as far as expansion, contraction, contact your manufacturer. You can contact myself, and we'll tell you what you're allowed. And we're going to say, you know what, we're going beyond a certain point. Let's move to another product. But you are allowed a certain degree of expanding. What pipe material comes to mind that you think would actually need to have this value taken into account? What type of pipe would you say? No. You're on the right track. Polyethylene. Polyethylene, man. She's breathing. She's breathing all the time, right? So that's one that you have to, get the skinniest coupling you can get. No, don't do that, all right? So we're going to come back to these pipe gaps. Even if your pipe is never going to deflect, I'm going to tell you, straight run, put a minimum gap in there. And the minimum gap is for the previous slide I just showed you. Because if you get more than one coupling and the piping material wants to be dynamic and expand and contract, at least have some gap in there. And this is not me making this up. This is all from AWWAC219. If you want deflection, then what they're saying, first of all, if you're going to meet C219, these are the minimum deflection values you should have. So we're saying on a traditional coupling, like this one right here, you should be able to achieve 2 degrees per side, or for a total of 4, okay? So what they're saying, what that means, pipe to sieve, that means if I took this coupling and I had it embedded on the wall, I should just still be able to achieve 2 degrees. On these wide range couplings, depending on your manufacturer, they're going to be able to accommodate up to 6 or 8 degrees of deflection, all right? Or 3 to 4 degrees per side. And I'll explain to you how that is achieved. They just have a wider gasket section, so a thicker cross section. So when I have a thicker cross section, what does that do to my annular space inside the coupling? I have more room to do this, okay? And when I have that proper pipe gap and the proper amount of gasket in there, that coupling can allow a lot of deflection. The key, though, is that we have to have those gaps in there. That's what's critical. We must have those gaps in there. This is an installation done in Red Deer, yeah. So, yeah, it's pretty easy to see those center lines aren't matching. Yes?
What about if it's a point repair with, say, you've got an AC break and you're dropping a spool piece of C900 in that same deflection
Yeah, you have one side that's bigger than the other, right? That's a great point. Yeah. So those values you just saw, how can I answer this? Those are, sorry. Those are minimum values. Thank you. Those are minimum values. So we say, oh, you can get 6 to 8 degrees. Then you say, Dave, I think this contractor's got 12 in there. What do you think? And I'm going to say to you, well, what's the pipe he has on the other side? Oh, he's got steel and C900. Yeah, he's okay. Right? Because we want to maintain that space inside there. So when you say I got AC on one side, I'm going to tell you, you're still able to achieve with our coupling 4 degrees on that side. 4 degrees, right? Per side. So because these wide range couplings work down to a small OD, so this particular one goes down to 4.46, so the 4.5 steel. Unofficially, you could probably do 8 degrees off that one side because we have so much annular space in there, right? Now, I'm not going to recommend that, by the way, but what it's there for is that when we put these couplings in and your particular operator doesn't want to, or contractor doesn't want to back to the shop to get that 5-degree bend, so they purposely use all that deflection in the coupling to do that, we've just used all the deflection available for that coupling to give, right? We just used it all. Soils never move, right? So now what are we asking that coupling to do now that you used up all the deflection in that coupling and we have a wicked cold winter? And soils are going to move. Like our soils hardly move here. Go out to the prairies. It's crazy. So you just have to be careful about that. I only mention that because I see a lot of people, we'll pull it, just, oh yeah, we can get that. And I know, necessity makes things necessary sometimes. But you just have to be knowledgeable. There's not an additional extra amount of deflection available if you use it all up at the initial installation. Okay? This one, all we're talking about is shear. So with shear, what we're talking about is these are flexible joints. Again, we want the pipe to float in that coupling. If I use this and I don't have any of those pedestals except the first one, my pipe's doing like this, I can tell you one thing, it's not floating. It's binding at that point. So we have to, and this doesn't really apply to if you're doing buried service at all, but if you do get above ground, that's why we have cradles or pipe saddles, pipe cradles to support the pipe so that it's not putting all that pressure on the coupling, okay? Because you think about it, when we do that, and that one pipe starts to bend, I'm crushing the gasket at the bottom, but what's it going to do to the gasket at the top? It's going to expose it. So my hydrostatic pressure going against something that's flexible, eventually, oh, your coupling's no good. No, it did exactly what it's supposed to do. We didn't support it properly. Really quickly, flange adapter. So the only thing you got to remember on this one, if you say, he said these couplings get 4 degrees deflection. I can pull this 4 degrees. No, we're using half the coupling, so we only get half that value, 2 degrees, all right? So there's all sorts of couplings, the transition couplings. So this is considered a transition, right? It's got red, blue by red. This means we can do C900 on this side and steel on that side, right? This is considered a transition because I can do steel on this side and I can do class 200 AC pipe on the other. So they're both considered transitions. If we do a transition, would you consider that joint to be balanced? Do you understand what I say what I mean when I refer to balanced? I'm just going to jump down here. Can you see my head if I jump down here, guys? No? Okay, I'll do it from up here. On one side, on the left side, that's okay, guys. On the left side, we have a smaller OD. On the right side, we have ID. Sorry, on the right side, we have bigger ID. Right? So we have pressure, and we have area. Right? So right now, what area is going to have less pressure as far as force is concerned? And I'm sorry, what area is going to have more force? What area is going to have less? Right? So this side will have more force. It's got a larger area. So what could that coupling want to do? It's going to want to, or I hear what you're saying, Or it may want to walk down. Have you ever seen that? The couplings start to just migrate down. If you have enough of a difference between those two areas, it's not the coupling's fault. It's trying to balance that joint out so that the forces are equal on each side. Okay? Not necessarily important on, let's say, 300 and under, but you start going above 300, you'll probably see it happen if you're energizing before you have any compaction on it. And those are just simple examples of transitions of AC to C900, another AC to C900. As a larger example, that's a transition. We have the same nominal, we have 30-inch steel to 30-inch PVC. So ideally, that's 32.00 by 30. That's classified as a transition. But you charge that up, that thing's going to walk. And you can see we've got harnesses on there in place just to make sure that doesn't happen. I say that because that's something that you have to consider. Water, it is a powerful vessel. And if it is not balanced in there, it will want to move. Who attended the last session for with the young lady from Pacific Flow? I heard a question. Somebody brought a question up on the thrust block. Yes, it was a great question. I would come back at you and say, what happens when I change the direction of a column of water in a 90-degree bend? What would you do? Exactly. The properties don't change just because it's a tapping sleeve. You got to eliminate that. What are we doing? We're changing water direction. The water doesn't compress. So it's going to want to keep going this way. So yes, I would absolutely drop. Now, the tapper shouldn't have, that's just basics for the operator to understand the fundamentals of a transient in a water system. Hey, man. Yeah. They own the vessel. They own the vessel. They don't own the system, right? So, but the same principle applies to what I'm talking here right now, right? Because look at this one. That's called a reducer, right? I just did one with Comox Valley Regional District. AC down to iron pipe size, it was a massive reduction. That will want to move, right? So actually, that's not necessarily true because the AC had to be at least that thick. So by the time we got to ID, they were the same. I've never seen AC so thick in my life. But let's just say it was this one, right? That thing is going to go flying off of there like a rocket, all right? So if you leave here and you're ever going to use a reducer, just know that smaller side is going to surrender really quick unless you've taken precautions to make sure it's anchored in some form or fashion. If this was steel pipe on the other side, I would say grind a couple clear, like 4 quadrants on the pipe and weld a chunk of angle iron at 4 quadrants. Why? Because if that coupling wants to walk down, it can only go down so far. All right? Or grab a split mega lug. E-iron has a split lug. All you're looking for is an anchor to have that thing come up against and stop. But it will move. Sorry, sir. Yeah. Okay, I'm going to do what Pacific Flow did. I said that would be my personal opinion. No. It depends on the area of reduction that we're doing. If I'm doing, let's say, 36-inch down to 30, yeah, I'm probably going to still recommend it. Actually, no, I'm just going to recommend it all the time. Because the cost of having that whole open excavator for another $200-300 for the vessel, I would always say, hey man, what are we talking about? Just put it on. It's a good ounce of precaution. There's this one we did in Medicine Hat, and that's AC. That's 36-inch AC on the other side. Who made this stuff back in the day? My goodness. And then going down to 36-inch PVC. So I think that was 44 something down to 38.30. So quite a big reduction. So what we ended up doing there is we actually formed around the AC side a big concrete form, and then we had two big tie rods coming out of there, tying back to some split ring restraint that goes on there. So the main thing I want you guys to remember is that these couplings, they're flexible. We want them to absorb all the shocks that go on in the ground. But that doesn't mean they're not prone to moving. So if you take one of these couplings from Smith Blair, they actually have little pictures on there say if this thing moves, it could go boom, right? So it's really important you look at your manufacturer's installation instructions. They'll all refer to that, but they will not restrain unless you buy one of these. And these are restraint couplings. Okay. Holy moly. Okay, so these are restraint couplings. We're going to speed this up here. These are having restraint they're embedded into them, sorry. So they basically couple and restrain at the same time. Flange adapters with a restraint. Basically, that one on the far left, that looks like it's just an MJ sleeve, okay? Some of the newer technologies out there from the Romac group, which is just fascinating technology. I'm so impressed with that. That's the Alpha, but they achieve the same thing. They keep it rigid and seal at the same time. Polyethylene, if you're using these, if you are using one of these and somebody says, you don't have to use an insert with that, hey, then the onus is on you. It's a very minor expense. Polyethylene will cold flow, right? If you push it here, it will want to move away from that. So how does a coupling work? It squeezes on a singular area. It's very possible we get into a thermal moment, that pipe will contract and you'll lose your seal. Put that insert in there, it's going to be a rigid hoop at that point, okay? There's two types. There's a fixed insert, there's adjustable inserts. They're available to you. So bolted coupling summary, connects plain ends of pipe the same size, connects pipes of different sizes, provides ease of installation and future accessibility for repairs and adjustment. You get angular deflection, it reduces vibration in the line, especially if you're off a pump, and take up minor lateral displacement, and more importantly, they isolate the pipe ends from one another. Oh, the other, I don't see that out here. If you go into Calgary and you put a coupling together, and you're doing some of their old cast or ductile to PVC or to another metal pipe, they make you put on what's called an isolation sleeve. And that isolation sleeve is basically going to take that end of the pipe and encapsulate it in gaskets so the two ends can't contact each other. What happens when we have two dissimilar pipes contact with one another? We get a galvanic action, right? So that, we don't see it. Metro's getting into that now. So installation of a traditional bolted sleeve coupling. So I'm just going to kind of go through this really quickly. Disassemble you have to take these kind of couplings apart, to get on the pipe. So the followers go on first. Then we're going to slide our gaskets on. Then we put our sleeve onto one side or the other. All right. Install the bolts and tighten if the carriage bolts are furnished, alternate the bolts. Oh, so what I'm saying here is in some cases, how many people in their times have alternated the bolts back and forth on the larger diameters? It's not a bad practice, and it sometimes can mitigate the coupling wanting to walk, because you pull from this side, you pull from that side. So they're saying that you can alternate them if you wish, and gradually tighten proper torque values listed below. Alternating opposite sides of the coupling. So basically, we never do it like a clock, 1 through 12 o'clock. We're always going to do a star pattern on that. And it doesn't hurt on the larger sizes to have a Sharpie on site, and we just number them. Retorque after line pressurization. I'm going to come back to that in a moment. I'm going to let this handsome young engineer from our company talk about this coupling installation, and I just went by it. Will it play? No. Guys, can you hover over that and just hit play on there?
And that nothing has been damaged during shipping or storage. Installation instructions can be found attached to the coupling bolt. Always read these carefully.
Okay.
Spare top bolt tape or standard pie tape, measure the outer diameter of the pipe. Using the instructions on the top bolt tape or the range printed on the body, determine whether to remove the inner gasket.
So there's an inner
If
gasket.
necessary, remove the inner gasket. If it is removed by mistake, simply align the gasket grooves and place the inner gasket back into the outer gasket.
So unlike these couplings where you need a whole bunch of different end glands and gaskets, These ones don't require that. You simply take the gasket out or you put it back in. We're going to lubricate
the
it.
gasket and the pipe. Refrain from using pipe soap or grease. Lubricant should be suitable for your application and compatible with the pipe type.
Do I need to lubricate for PVC? No. Am I going to lubricate for AC or ductile? If she's got a really good dimple pattern, it's not going to hurt. It's not going to hurt. We want that gasket to flow into every imperfection on the pipe. So we slide it on, we center over, we make sure we got our pipe gap set up properly.
Completely onto one pipe. If reducing, slide the coupling onto the pipe with the smaller OD. Place the second pipe into alignment with the first pipe. Measure the gap and compare against the maximum gap listed on the installation instruction. Center the coupling over the gap. For the 420.
So in that one, what was the biggest difference between this assembly and that assembly that you saw there? These are what's called a stab fit. No disassembly. It just slides right onto the pipe. So at 2 o'clock in the morning, you drop the nut in the mud. You say, oh, shucks. It doesn't happen with these ones. You just pull them out, slide her on, and then the next thing we're going to do is go to torque.
Calibrated torque wrench is required. Torque specifications can be found on the installation instructions. Torque fully and evenly in uniform increments, alternating bolts. For 16-inch sizes and larger, maintain equal gaps between flange halves. After pressurizing the pipeline, check nuts for proper torque and retorque if necessary.
Yeah.
Top bolts 6-inch and larger employ Smith-Blair's patented.
Yeah, we've touched base on that one. That looks real easy. This is a repair I just did a couple years ago in a utility in the Fraser Valley. That is a wastewater line. Wastewater line, right? We can't isolate. That's the best we can do. Who wants to get the Tyvek on and do those bottom bolts up? Get the straws out, right? Draw the straws. Yeah. There were no new guys there that day. We get out that chunk of pipe and it's all rotted at the bottom. It was funny, that pipe had like a veneer of steel at the bottom. It was so thin. The top, it was all pristine still. But with that, because we can't isolate, we can simply have the guy stay nice and high and dry at the top, do it up. That was a 24-inch line. Yeah, we started in the just after lunch, and there's a big story behind this. We had to build a road to get there. I'd rather not say at this point. I don't know about you in the township there, but okay. Okay. Anyways, nobody had to go and get the Tyvek on and go underneath the pipe to do it up. So in this particular instance, this new style coupling was really beneficial to the city and the operators. And it was able to be repaired, and there's a big story behind. We really averted a disaster there. That's another story that I could sidebar with you there. But there was an issue there that when we tightened it up, there was no steel thickness left on the bottom, like none. It was like this. It just crushed it. So we had to cut further back, grab another spool of pipe until we got, and we barely had enough. In fact, we barely had enough steel. So the practice from manufacturer for application, retightening after application of torque, it's best to fully understand each other's manufacturer's recommendations. For standard traditional coupling, the cross-section of the coupling gasket is such that it allows for maximum application of torque during and compression at initial installation. Factors such as pipe movement, temperatures at time of installation, and pressure changes can play a role causing the gasket to creep or relax. In these instances, reapplication of torque is recommended. Real quick hands, how many of you guys will put these on, then leave the hole open for an hour, then come back and retorque it? Okay, there's one. And I'm not saying as some manufacturers insist on it, right? And there's a reason for it. For wide range couplings, the gasket cross section is much larger. Therefore, the potential for gasket creep is much greater, and therefore proper torque application is much more critical. For this matter, it is strongly recommended that the installer follow each manufacturer's installation instructions. So I I know the other manufacturers recommend it, and it's for good reason, because with that amount of gasket, a thermal change, the gasket will settle and it'll creep. What does that do to your torque? It's gone. That's why they say, go back in there and tighten it up. With our technology on the Smith Blair, it has the double acting technology on the 6 inches and up, and you get that tangential pull, you're getting maximum compression. If you leave the hole open and you energize the line and it's not backfilled, I guarantee you that coupling is going to move to some degree. If it moves, you got to go back in there and tighten it, because the minute that gasket moves from its initial position, what happens to our torque? It's gone. Now, it might only change 2 pounds. It might change 5 or 10. But if it moves, you've lost whatever torque you've put in there initially. Okay? All right. As with any fitting that is going to be buried and forgotten about, the long-term success of your coupling will be determined by the level, let's just say of, workmanship demonstrated by the installer. Taking time to consider all factors involved with your coupling installation will go a long way in making the couplings flexible seal a long-term seal. And that will make you do a thumbs up, man. All right? Guys, we made it. That's it. No more after this. Thank you for your time today, guys. And I don't know if we have any time for questions left.
We have like 4 minutes for questions if anyone has anything. I think we have one online. Stephanie? That's okay. All right. So, would you recommend not restraining around couplings on straight shots in order to allow pipe movement within coupling?
Well, okay, so why are we restraining, right? We're restraining because we feel there's a potential that the pipe could pull out of the joint and we lose our seal. So that is entirely at the discretion of the installer. And if they feel that there is a threat that that joint could pull apart, you absolutely, everything else is off the table. You have to keep that from happening. That is going to be a design consideration as to what it is that you need to accommodate in that pipeline. And there are ways you can restrain and still allow some movement, but it's a great question, because the minute you restrain over a joint, what's happened to all those deflection values? They go down. They're not eliminated, but they go down. That's a good question.
Any other?
I'm sorry? You have to get creative on AC. You have to get creative, yes. Or haywire, don't forget the haywire, yes.
Any other questions? All right. Thank you very much.
We made it.
That was
We
very
made it.
good.
Thanks, guys.